Hello, our most valued student. My name is Confident. Welcome to our revision session, and this is for engineering science in N2. And the topic that I want to look at today is statics, and in particular, we are looking at moments, the moments of a force. So before we look at some previous papers, I just want to bring a few kind of basics which I assume you might be knowing, but I just want to make sure that whenever I work on these questions, we are on the same page. So let us look at the basics here. And the first part is whenever you're dealing with moments. Now, when you define moment of a force, remember it's moment of a force. It is equal to force, which is the perpendicular force. In this case is perpendicular force times the distance from the fulcrum or the pivot times distance from fulcrum. So now, what are we talking about when we're talking about the moment of a force? Suppose I have a beam. A beam is like, if I've got my beam like that, usually they will say it is light, a light beam, meaning it does not weigh much. So this beam, it will have some pivot, which is the fulcrum. That's what we mean when we're talking about the fulcrum. So this beam will have a pivot where it is supported. So this is the support. And when we are now talking about the distance from the pivot, so we are saying we have this particular beam, and the distance of this beam, I'll call it D. This is the distance from this point, which is the fulcrum. That's what we mean by the fulcrum or the support. And then sometimes we say the pivot, that is where this beam is supported. Now you can see that this beam, the force is directed upwards, and because of that, that's why we say perpendicular force times distance. So when we are talking about the moment of a force, we are saying it is force times the distance. So you can see where the force is. The force is being applied at this point. So this is where the force is applied. And the distance, this is the distance that we're referring to. So when you're saying force times distance from the fulcrum, if you know the distance that is from this point, that is where the distance you start, up to that point, and you multiply by the force that is applied due to at this point due to the support, we call that a moment of a force. But now another thing that I want to emphasize, if you look at this beam, if you let go of this beam, you will see that this beam is going to start falling this direction because there is no support here. So it will start falling this direction, and you can see the direction that it is taking this kind of direction, and we call that clockwise, because we'll be taking clockwise moments and anti-clockwise moments. So when we're talking about clockwise, we are saying if I remove, or if I don't have a support at this point, what will happen if only the support is at this point? You'll see that the beam will go downwards here, and when it is going downward, we call that a rotation that it will take. And that kind of a rotation, you can see that if you have a clock and you have your 12, you have your 6, you have your 3, and you have your 9, and if this is the clock, remember the clock is moving in this direction. So from 12 to 3 to 6 to 9, so you see that is how the clock is moving. So that's what we mean when we say clockwise direction. Now if I do the opposite part now, and by the opposite part is if I remove the support at this end and I put the support on the other side, let me leave that for now. If I remove the support and instead I put my support now at this point, so this is now my support. Now the question is, what will happen to this beam? This beam will start moving in this direction, meaning it will move more like in that kind of rotation. Again, back to our clock. If I have my 12 and I have my 6, my 3 and my 9, so now you see that the beam is changing movement. It is starting from 12 going to 9, going to 6, going to 3. So the movement now of the beam is in this direction. As you can see, the direction that it is moving. So we call this anti-clockwise. So this is anti-clockwise rotation. So whenever we're talking about clockwise and anti-clockwise, remember we are looking at what the beam or how the beam is going to behave if we remove a support at that point and consider the support on the other side. For example, if the support is removed from this point and only the support is on the other side, this beam definitely will move down. And when it is moving down, you look at the distance that it is doing. We are saying that movement is an anti-clockwise movement. The opposite is true. If you put the beam on the other side, like that, and then you remove that support, this beam will start moving down here, and that movement is called now clockwise. So in our calculations or in our methods, we are going to be looking at in this case the sum of moments. So another thing that I'm bringing in is the sum. So if we're saying sum of moments or sum of clockwise moments, so it will be, this sign means sum of, that's what this sign means. So if I say something like this and then I do a rotation like this, I'm saying this is sum of clockwise moments. Right? And then if I do the other one, whereby I'm saying like this, and then I'm doing that, I'm saying sum of anti-clockwise moments. So remember, such is very important so that whenever we're working, you'll be able to remember why or what is what. So this is what it means. And then if you look at this, we are now coming to the law of moments. And how do you state the law of moments? The law of moments say sum of clockwise moments is equal to sum of anti-clockwise moments. So remember that. So if we're saying sum of clockwise moments is equal to sum of anti-clockwise moments, that's what we're meaning. Now, the last thing that I want to bring to your attention again, so that we finalize this part, let me again have my beam. So if I have a beam like this, this is my beam, and it's light, it's a light beam. And now if I have forces that are acting on this beam, for example, I can have a force that is acting at this end of the beam. So that force, I'll call it F1. So you can see when a force is acting like that, and I have maybe a support on the other side of the beam. So now this particular force is going to push this beam going down, and you can see again the rotation, it is anti-clockwise rotation. So that will be a force that will cause the beam to rotate anti-clockwise. Are you seeing that? Now let's say I have got another support somewhere here. I have my other support on this beam. Now I have a force here, I'll call it my force 2, that is acting on this particular beam. And now if I ask you to say what is the effect of force 2 on this beam, you can see that force 2 is pushing this beam in this direction. You can see that if this is my line of reference. So if I remove this let me just remove this force. If I remove that and I ask you what is the effect of F2 on this particular beam, and you are using this as my pivot, you can see that it is going to push this beam down, and we'll call that a clockwise force. So this force will be pushing this beam in a clockwise direction. I hope you are able to see that. So whenever you're talking about moments about, you need to tell us which support are you talking about. So at this stage, I'm using this support, and when I'm using this support, you can see that these two forces, F1 and F2, are going to have two effects about the pivot. So the first one is going to push, as you see, is going to push the beam downwards and rotate it anti-clockwise, and the second one is going to push the beam also downwards but make it rotate clockwise. So that is very, very important. So whenever you're saying moments about a pivot, you need to first identify which support are you dealing with. If you are dealing with this support here, if I'm dealing with this support, what I must do is I need to first ignore this particular support and ask myself, what will be the effect of these two forces about this side or about this pivot? So you can see that the first force will push this beam downwards and the rotation is anti-clockwise. So remember such, and you look at the second force F2, it will also push the force downward, and when it's pushing downward, the rotation is similar also here, it is anti-clockwise. So you can see now these two forces, they've got the same effect about this end. They will have a similar effect, but when I change them and I put them, if you remove that and I change my pivot to say my pivot is now somewhere here, you saw that the same, a different scenario occurs whereby the first force, which is this F1, will have the same anti-clockwise. But if you look now at F2, F2 now has changed. In this case, F2 is making the it's still going downwards, but it is making this beam to rotate now in a clockwise rotation. So you need to be careful and you need to be aware where is the beam and what is the effect of that force whenever that beam is going to be turning. So remember, when I'm pushing this thing down like that, I will cause it to rotate like clockwise along that. So it will be more like I'm saying here, just to show you in a way, just that my diagrams won't be good, but I just want to show you what it means about that. For example, F2, if I have my fulcrum like that, so this effect of F2, you can see what it will do. It will keep pressing down. So this is my F2. So you see where it's rotating. So I can continue drawing it now further. That is my F2. So you see what it keeps doing. That's my F2. And then that's what it's doing. It's making this beam to rotate. But now if you look at F1, what it does, F1 in a way is doing the opposite. So F1 is pushing this direction. After some time, you will have F1. This is F1 pushing in that direction. So again, if F1 continues, you'll see something of this nature like that. So you've got now F1. So now if you look at the direction, you can see that this direction is an anti-clockwise direction that is happening. And if you look at F2, the direction is clockwise direction. So those are the basics that I wanted to bring to you so that whenever we're looking at calculations, you will be able to understand what we are dealing with. Now, let us look at a few examples. As I was saying, this is a question that was written in November 2019, and in this question, as you say, it was a November 2019 question. That's what I'm bringing to you guys. I bring you practical questions that you can even use for your exams. So this is November 2019, and this question, I'm only focusing on moments of a force, which is question number 2, and question number 2 is statics. So if you look at your paper, usually it's arranged in that format. Question 2 mainly talks about statics. So if you look at this question number 2, and then the first part, it's statics. It says question 2.1, define turning moment. So you need to know the definition of a turning moment. So I'm not going to write that one, but I already have it. It says, we did talk about it, to say how do you calculate. That's what it means. How do you calculate the moment or the turning moment of a force? We are saying it is the product, as you can see there. We are saying it is the product of the perpendicular force and the distance of the force from the fulcrum. That is the first part that we looked at, to say whenever we are dealing with this moment of a force, we are saying it is the product. So moment is equal to the product of the force times, we are saying that force is the perpendicular force times the distance from the fulcrum. And we did look at it to say you are having your fulcrum there, and then you have got your distance here. So now that force F, that is the force, and the distance is that. So if you multiply F times D, we are talking that as the moment, and the units is Newton dot meter. So these are the units. Remember, F is in Newton, distance is measured in meters. So this is the units of that particular force. So it is the product of the perpendicular force and the distance of the force from the fulcrum. So that is that part of the definition. And then 2.2, it says a uniform beam of 15 meters has two supports, A and B respectively. Support A is 3 meters from the left end and support B at the right end. The beam carries a point load of 100 newtons on the left end. Another point load of 250 newtons is 7 meters from the left end, and also carries a point load of 150 newtons, that is 3 meters away from the 250 point load towards support B. Ignore the weight of the beam. So it's quite a mouthful of statements there, but we're going to analyze each and every statement there. Then it says make a neat labeled drawing of the beam, and then they're saying clearly show all its dimensions and the loads, and then they want to give you formats for that. So if you're going to make a neat label sketch of that, let's do that. But we need to ensure that we get all the 4 marks that are given there. So let's look at what they're talking about, one statement at a time. So you are given a uniform beam, meaning the way you're drawing your beam, don't make it uneven, so it must be uniform. A uniform beam which is 15 meters, that is key, take that, it's 15 meters, has supports A and B respectively. Okay, so you start with A and then you follow by B. Then they talk about support A now. Say support A is 3 meters from the left, so it's 3 meters from the left, so that is also key, from the left end. So we start looking at that. I can now draw that statement. First, let's have the first part of the statement. We are dealing with a uniform beam, so I'm going to have my uniform beam like that, and so uniform, as I said, make sure that in a way it is made more parallel on the ends. So suppose you can do actually better than me. So this is my uniform beam, and we are saying this uniform beam is supported at point A. I think you saw that they say there is a support at the end. So we have got two directions, the left and the right, and this is my left side. So this particular beam here, there is a support here. So that is the first support, and they call that support, it is support A. And then they say, let me just read again if I'm doing right. They're saying support A is 3 meters from the left end. Actually, this is wrong. I need to draw support A 3 meters from the left end. So this is not the part, this is not 3 meters from the left end. So now what I need to do, I need to start marking my beam to say the distance from this point. Maybe to remember, this is a sketch, you might not be very accurate, but you can just have an idea. For example, from here to here, you know that I can just do it a sketch on top like that, then I will erase it just to have an idea, because the final diagram, you don't want it to be clumsy. So this is the length of the beam. They're saying this beam is 15 meters, remember? So you know I'm dealing with a 15-meter beam. So I will erase this part later, but just to have an idea what is what. So, and also my measurements, you can use your ruler, but it's not necessary. As I said, in this case it's just a sketch, just that you need to be a bit more accurate. So if I can now deal with that as roughly my center, so it will be, in this case, my 7,5 here, and then the center of 7,5 is there, and the center of 7,5 is there. So here you expect it to be around 3.5, and then here you add again 7.5 plus 3.5. I think it will be 7.5 plus 3.5. It gives me 11. So you expect this part to be 11 meters. All right. So this is just a rough kind of a thing. So they said that when you start dividing it into what they say, it is 3 meters, just in a way. So you think, or you put maybe 3 meters somewhere there. This is 3 meters. So if I now come to my labeling, you can see that I can make that now be equal to 3 meters. So if I do that and I do that, that's the first part that I'm given. So that is 3 meters from the left. Remember, this is my left side in here. All right, this is my left, and this is my right. I'm just taking it a bit slower so that you can just have an idea what we're dealing with. So they are saying here, a uniform beam 15 meters has two supports, A and B respectively. Support A is 3 meters from the left end. So that is what they were saying here. So this is my left end, it is 3 meters, and here expect me to have support A just above that 3 meters. So that is my support A there. You see that? So that's what I'm having. And then let's find out where is support B. And then they're saying support B is at the right end. So we need that support B at the right end. So if I come to the right end also, and this is my right, and the right end is that part there, that is where I find my support B. So that's what I'm having. So this is that at the moment. Then continue. Then they are saying the beam carries a point load of 100 newtons from the left end. There is another statement, a point load of 100 newtons from the left end. So the beam carries a point load of 100 newtons on, not from, on the left end. That is very important. It's on the left. So which means you go to the left, just like they say it here, the beam support be at the right end. So also on the left end, just like in B. So you come to your beam here on the left end. You have sorry about that, a point load will be similar to the arrow we are having. So we will have the same arrow like that. So that is the first one that we have, which is 100 newtons. I hope it's clear there. Let me just try to write it more clear. So we have 100 newtons, that's the first part. And they are saying another point load of 250 newtons. So there is another point load of 250 newtons is 7 meters from the left end. So there is another point load of 250, which is 7 meters from the left end. So we come from, remember our reference point here is from the left end. So I am from the left, which is this direction, and I need to find 7 meters, which is somewhere there. So this is where I get my 7 meters. So I will have my line to say at this point here there is a point load somewhere there. There is my point load, and they said that was 250 newtons. You see that? And then in 250 newtons, now if this is now 7 meters, now you don't write 7 meters. What you do, you come here and say, already I have my 3 meters here. So for me to move from that point to that point, when I already have my 3 meters, so what is the distance from here to here? It will be 4, so that you say 4 plus 3, it will give us that distance of 7. You see that? So I need this distance here to be 7, like this. I need this part, it must be 7 meters here. So for it to be 7 meters, it means from here to here it has to be 4 meters, and from there to there it has to be 3 meters. So when I use that, I'm going then to have that, say that, and then as I said, you write that as your 3 meters, your 4 meters. So that is how this thing, or this beam, slowly you're creating that beam. Then the next one says, the statement continues and says, from the left end, and also carries a point load of 150 newtons, 3 meters. Okay, there is 150 newtons, there is 3 meters away from the 250 newtons point load towards support B. So you see what they're saying now? They're saying you have another one which is 150 newtons. Let me just clear this. So you have another load of 150 newtons that is 3 meters away from 250 newtons point load towards support B. So you go to the 250 newtons, go 3 meters away in the direction of support B. So what they're saying here is we have got our 250 here. Now towards support B, this is the direction, but you must move 3 meters. That's what they're saying. So if we can do that, we are going to have at this stage a distance. If you are saying 3 meters from, so I'm going to also have a distance that was similar to that size of a distance, because it is the one that is 3 meters in a way. So I'm going to now mark my beam with almost an equal kind of a force here, like that. And they say that force was 150 newtons. Right, so I'm just, as I said, I'm taking it slower, but next time I will be doing these much quicker, with the assumption that the first question was making more sense. So they're saying this is 3 meters away, so it's 3 meters away from the 250 towards support B. Are you seeing that? So that is why I was doing what I was doing. So now looking at this last statement, and then says ignore the weight of the beam, make a neat label sketch clearly showing all the dimensions. Now they wanted to show all the dimensions, and we have managed to show part of the dimensions, but there's a dimension left between the 150 newtons. This distance is still missing there, so you need to tell us, or you need to calculate and write that distance there. So if I start from here to that distance, we need to find out what is that distance. Then that is what they mean when they say it's a fully labeled diagram. Now remember, this beam is 15 meters. So now you have the 3, you have the 4, you have the 3. So if you add this 3 plus 4 plus 3 minus 15, it must give you definitely the outstanding size which you are going to write there. So if I say 3 plus 4 plus 3 minus 15, I'm getting 5. So which means it says minus 5, but obviously I need a positive answer. So I'm getting this to be 5 meters. So this is 5 meters, but when you say 5 meters plus 3 meters is 8 meters. 8 plus 4 is 12. 12 plus 3 is 15. So this is what they mean when they say this is a 15 meter beam divided into that. So what you do, you can now take off that just so that your work, remember as I said, this was just to show or to have a way of dividing your answer, your beam, into a very neat sketch, which even on the beam you can just do that to show that this was your beam, just to make it neat. So that's what we're having. So if in this, your question that follows is based on that, it says that's 3 point, if I'm looking at here, 3.2.1. so let's remove that. So we are done with this. Let's look at the next question. 3.2.1, the question says, 2.2.2, the question says calculate the reactions on both supports by taking moments about each support in turn. So this is now 4 marks. So now that is what we are looking at. The main thing now is the calculations of that. So how do you go about calculations? Alright, now you have to state now, say when you're doing your calculations, take moments. They said about each support. Let's start with moments about A. So if you're saying take moments about A, you are saying if A is my line of action and everything is resting on A, how are these forces going to behave if this is the line of action? It means, you see, this force will do that direction. Actually, I think I needed to correct my first statement now. This force, you can see, it is going to pull this beam or to rotate this beam in an anti-clockwise. You see that anti. And then what about the 250? You see, it is going to do the other way around, which is clockwise, even this other one will do the other way round, which is clockwise. See that? And what about B? B will do the other way round, which is in this case anti. So that is what actually is happening there. I needed to correct the first statement I think that I made. So whenever we are now going to be calculating, to say take moments about A, we are looking at the 100 newtons. So we are saying 100 newtons will do that. So it will be sum, remember the formula, it will say sum of, start with the clockwise moments and then you do that. Its sum of clockwise moments is equal to sum of anti-clockwise moments. That's what it means. And then I still need my space there. So now the sum of clockwise moments, if you look at the ones that are clockwise, remember we are focusing on A. Now A, about A, this force will be 250, goes the same direction if this is my line of action. Even 150 goes that direction. So that's what I'm seeing as clockwise there. So remember the aim is to multiply the force, which is now the first one is 250 times distance from A, you said it was 4, see, plus with another 150 times what is the distance of this force from that line of action, which is A. So it is 4 plus 3, which is 7 meters there. So we will have 7, and these are the clockwise moments now, which is equal to sum of anti-clockwise. The anti-clockwise about A, there is the force 100 newtons 3 meters away, that is producing an anti-clockwise movement. So it's 100 times 3, and then plus, you look at B. B, as we said, from A, it will also do an anti-clockwise movement, and that will be B times, now if you look at the distance of B from A, it's 5 plus 3, which is 8, plus 4, which is 12. So that is B times 12. And then after that, you need to add the left and the right, and then find the final answer. So you are going to say 250 times 4 plus 150 times 7, and our answer there is 2050 is equal to 100 times 3, which is 300, plus B times 12. And then what we need to do, we need to take 300 to the other side, which is 2050. Now when it jumps, it changes from positive to minus 300, is equal to B times 12. And then when you subtract 2050 minus 300, you get 1750 is equal to B times 12. You divide, in this case, by 12, so that you can get your answer. You can see that now our B is equal to 1750 divided by 12. It will give us 145,83. So I've got 145 to 2 decimal places, 83 newtons. So that is the first answer that we have for B there. So that is when we're taking moments about A. Now what about if we now just have to work everything in this space so that I can see my beam. So now let us take moments about B. So I'm going to write here take moments about B, meaning now my B is my focus. So if B is my focus, I ask myself, how will these forces behave if the support is now at B? Now you can see that this force, if the support is at B, the 100 Newton will do that, which is anti-clockwise. The 250 will do the same, which is anti-clockwise. 150 will do the same, which is clockwise. The only force that will oppose, you see, it is the A, which will be clockwise. The rest forces are anti-clockwise, and only A will produce a clockwise movement. So now if I start doing the calculations, it will be 100, the 100 Newton force times B. Remember, you are adding the whole beam A. From this point to that point, it was to B, it is 15 meters, because that's the length. Remember, the 100 newtons is at the far end, so it's 100 times 15 plus, you look at the 250. What is the 250 from B? So you see 250 is 3 plus 5, which is 8 meters from B. So we're going to say 250 times 8, and then plus the 150 is 5 meters away. This is equal to, what about A from B? It will be A times the distance of A from B is 4 plus 3, which is 7. 7 plus 3, which is 12. So it's A times 12. Then when we use the calculator again, we have 100 times 15 plus 250 times 8 plus 150 times 5, and then this is 4,250 is equal to A times 12. Then I divide by 12 on both sides so that I can get my A. So when you divide 4250 divided by 12, it gives me 354,16, which is 354,17. So I've got 354,17 is equal to my A. Remember, it is in newtons. We mustn't forget the units. So this is what I'm having in this case. So in other ways, my A, or if I write it properly, A is 354,17 newtons. So this is the answer to the question when they say calculate the reaction at both ends by taking moments about the support in the 10. But now I need to test my answers here. Remember, you can test here your answers. So how do you test your answers? Some questions, they will actually say test your answers. Now how do you test? What you are doing is you're going to look at all the sum of forces that are facing, for example, up, must be equal to the sum of forces that are facing down. So let us look at our analysis. We have got all the points. This is facing down, that is facing down, that is facing down. So you look at all the forces that are going down, which is 150 plus 250 plus 150. So those are facing down here, which is the 100 plus the 250 plus the 150. And then you look again at the forces that are facing up, which in this case was our A and B. They are the ones that are facing up. These forces must balance. And then we did calculate A and B. We said A was 354,17 and B was 145,83. If this balances, it means your calculation is correct. If they don't balance, go back to your calculation and correct it. So if I say 354,17 plus 145,83, it gives me 500. So I've got 500 newtons on the other end is equal to, then I also add the other side, which is 100 plus 250 plus 150, and again it is 500. So you can see now that this balances, which means my B and my A, they are correct as far as this is concerned. So that is how we work on this question. As I said, I took quite some time focusing on this question, but now let us try to be a little bit faster with this one. This is a July 2019 question, as you can see, and I'm looking, or the focus here is on moments. As I said, I'm not going to be focusing on other parts, but it's on statics. Question number 2, you see that one again, and question number 2 deals with moments. So look at 2.1. It says a light horizontal beam is 10 meters long. So we have a horizontal beam that is 10 meters long, that is shown here, and is loaded as shown in figure 1. So let's look at this beam and study it. We have got supports M and R, and the first support is 1 meters from the end, and then the 400 newtons. The 400 newton support is 1 plus 3, which is more like 4 meters. You see that we have got a 4 meters distance there, and then that's where they want to confuse you here to say from R. You see they mixed up, and they mixed up these distances, and we have to be in a way careful how we analyze that. Now the 150 is not difficult. From M, you add that, you add that, you add that. That's not a problem. Now the challenge comes when you want to find the distance of the 400. If you look at the distance of the 400, or let's start with the 200, the distance of the 200 from that end, and the 400 from that end, and the 50 from the reaction R. So if this is to be divided, we need to find that particular distance in a way. But let me not get ahead of myself. Let's look at the questions. It says ignore the weight of the beam and calculate the reaction R of the beam. So they want us to calculate the reaction R of the beam, to say what is the reaction R from the given measurements. So now, in other ways, they are saying take moments about R. So if we're going to take moments about R, we need to be also sensitive to the distance. As we said, we need to know what is this particular distance, because this distance will determine our distances from this part of R. So now remember, you are given that, I just want to make it like this so that I don't close that 4. So we know that the whole distance that we're given there is 4 meters, but look at the bottom. The key is in this part that you're given there. Let me not make an error. Look at that now, and then again look at that. We are told that this beam is 10 meters long, so we know at the bottom 1 plus 3 gives me 4 meters here, and then from this point to this point it has to be 3 meters, so that it will add up to become 7 meters. So you can see that from here to here it is 3 meters. Now from here to here it has to be 1 meter, so that 3 plus 1 will give me the 4. So that now we've managed to crack this distance. We know that it is 3 meters and 1 meter. So now we have to take moments about r. Now if you take moments about r, you have to ask yourself, what are the effect of these forces about r? Now look at the 200 Newton. It will rotate. You can see how the rotation is anti. You look at the 400 about r, it's anti. Remember, this is our main part. We're focusing. It will cause this beam to go down, and in this point it's going down, it's going down. But now look at the 250 about the 150 about r. This force will cause it actually to go in the other direction, which is clockwise. Are you seeing that? Now what about the m with respect to r? You can see that the m is going to push it up and also do a clockwise. You see that? So now we can now come up with our formula. Remember what it says? It says sum of, let me just do it just here. I think I can space something. Remember, it says sum of clockwise moments is equal to sum of anti-clockwise moments. So we're going to look now at the clockwise moments that we're having, and the first one is this force. It is clockwise, so which is 150 times the distance of the 150 from r. We say it was 1 meter, plus the next one that is clockwise is the m here, which is m times the distance of m from r. You can see that what they gave us there is 7 meters, because it's 1 plus 3 plus 3, but at the bottom it's clear there. You see that this is equal to the 200 newtons. You can see that's the one that is anti-clockwise, the 200 newtons, but the distance of that is 200 times, so we have got the 3 meters, and then we also have the 3 meters, so it's 3 plus 3, which is 6, and then plus the 400 newtons, which is 400 from r is 400 times 3, so you've got 400 times 3. So let me just have that. So it's 400 times 3. So these are the way you're going to do your calculations. So what you have is 150 plus m times 7. This must give me, if I use now my calculator here, it must give me 200 times 6 plus 400 times 3, which gives me 2400. So now m times 7, you take 150 to join that, it will become negative, which is 2400 minus 150. Remember, it's jumping the equal sign. So m times 7 is equal to it says 2400 minus 150, which is 2250. So what you need to do, divide by 7 so that you get your m. So what is m? That is the reaction at in this case the reaction at m. So if you work, that is 2250 divided by 7, which becomes 321,43. If you round off to 2 decimal places, 321,43. So that's 321,43. That is in newtons. So I'm going to keep that one to say, they say the reaction m, says, okay, the first one was the reaction r, so I'm going to write it here, is 321,43 4, 3. All right. So now let us look at the other one. I'm not gonna erase that just to keep my working. Question in this case 2.1.2, ignore the weight of the beam and calculate the reaction M by the beam taking moments about support R. The first one was ignore the weight of the beam and calculate the reaction R of the beam. So we've calculated actually the question, I did the question the other way around. I was supposed to take moments. This particular question, I didn't read it right. I was supposed to take moments about this is taking moments about M. That's why it says ignore the weight of the beam and calculate the reaction M of the beam by taking moments about support R. So this is actually the question for 2.1.2. Now I'm looking now for question for 2.1.1 is the first question that I was supposed to do. It says ignore the weight of the beam and calculate the reaction R. If I'm to calculate reaction R, I must take moments about M. I think that. So now if I'm taking moments about M, what I'm going to have is that with to say if this is my focus here, now you see this force will turn like that, it will turn like that, it will turn like that. So all these are clockwise, so its sum of clockwise is equal to sum of anti-clockwise. So let's look at the clockwise first. We have got the 200 from M is times 1 plus we've got the 400. Now again 400 is 3 plus 1, which is 4, plus we have got the 150 there times, now it's 150, it's 4 plus 3, which is 7 plus 1, which is 8. This must be equal to, look at the one that is going to produce an opposite effect, which is R. See, R will produce an anti-clockwise. So what is the distance of R from M, which is equal to R times 7 in that case. So you can use the calculator then to find that, which is 200 times 1 plus 400 times 4 plus 150 times 8. See that? It will give me 3000. So I've got 3000 is equal to R times 7. Divide by 7 on both sides so that it will give me my R. Therefore, my R is equal to, in this case, 3000 divided by 7. And if I do that, it's 428,57. So it's 428,57 newtons. So that's what I'm having in here. It's supposed to be 428,57 newtons, and this one is down there, which is 321,43. Remember, we said this is question 3.1.1. This was 3.1.2. I just didn't read the question properly. It was supposed to be when they say calculate reaction R, meaning take moments about M, and then vice versa. So this is, see, now it's giving me R in that case. And then look at the last question there. It says I need to check my answers. See, now that is where saying some questions they say check your answers. When you check your answers, you are saying the sum of upward forces is equal to the sum of the downward forces. That's what we're saying. So all forces that are facing up, it's M and R. So you say M plus R, these are the forces that are facing up, is equal to the forces that are facing down, which is 200 plus the 400 plus the 150. All these forces, as you can see, they are facing down. So now what is M plus R though? M plus R, we said M was in this case, this is my M, this is my R. So M is 321,43 plus my R is 428,57 is equal to the 200 plus the 400 plus the 150. So now let's test that. In the first one, we have got the 321,43 plus 428,57. It gives me the 750. So I've got 750 here. Newtons is equal to. Also, I test the other one, which is 200 plus 400 plus 150, and it gives me also 750. So you can see that my forces are balancing. It means my answers in this case, they're correct. So you can use that as a test also, when even if you're not told to do that, you can use that as a way of testing your answers. Now the next questions, that's question 2.2, still continuing on that question. 2.2, these are common questions that I want you to master, so that you just ensure that you don't lose marks on this part. They like this question to say define the term couple and also give one examples of couples. Please remember that. These questions, you need to know them. It's 2 marks and 1 mark. Now, what is a couple? So this is the definition here. It says it is a pair of forces equal in magnitude. They'll give you a mark there. So it is a pair of forces equal in magnitude turning in the same direction about a fulcrum or turning point, but situated on the opposite sides of a couple arm. Then they'll give you that. So it is a pair of forces equal in magnitude turning in the same direction about the fulcrum or turning point, but situated on the opposite side of the couple arm. Please remember, this is I will say NB. You need to know this definition. They like to ask that. And the next thing that they like asking is give one example of couples. And the common answer that you can bring here is you can use a water spray, that's where you use couples, door handles, that's where you use couples, wing nut spanner, and then a thread cutter. Now don't forget, you can just master all these 3. Master at least make sure you master 3 of these, because they usually sometimes says give 3 examples, give 2 examples, or give 1 example. The definition is a must. The examples, it's a must. Don't forget this. I hope you are benefiting from this, guys. Now let us move on to the next question. Again, I'm bringing more questions to you guys. I'm bringing more questions to you. But it is good. This is a complete guide to looking at moments. So that's why I'm looking at all these questions. So you see this question, it was in November 2018. And in this question, I just took different questions. They've got different approaches so that I try to cover almost everything. Now question 2.1 here says state the law of moments. It's a very common question also. Very important to master. Now what does the law of moments say? The law of moments say the sum of, that is the definition of the law of moments. This is what you'll be defining. Remember that. We are defining this, what we've been talking about. What does it say? It is, the law of moments says the sum of clockwise forces about a fulcrum is equal to the sum of clockwise anti-clockwise forces about a fulcrum. So I repeat again, it says the sum of clockwise forces, this is the clockwise forces, about the fulcrum is equal to the sum of anti-clockwise moments about a fulcrum. I said forces, but I'm supposed to use moments. The sum of clockwise moments about the fulcrum is equal to the sum of anti-clockwise moments about the fulcrum. That is the definition of the law of moments. So remember that one is very important. All right, so let us look at the question. In this case, question 2.2 says a light horizontal beam is 12 meters long and is supported at A, which is 2 meters from the left end. They didn't indicate though, but they're telling us it is 2 meters from the left end, and B, which is at the right end. You can see that ignore the weight of the beam. So let's look at the information. Now the first question says calculate the magnitude of the force F if the beam is to be in equilibrium. So this beam is in equilibrium. They want the magnitude of that force F. Now there's something interesting though they did here. They gave us a force there facing down, a force there facing down. F is facing down. Look at the arrows. It is going down, it's going down, it's going down. And they also gave us A that is facing up and B that is facing up. So in other ways, they calculated all these forces. What they usually want you to calculate is calculate the forces or reactions at A and at B. And then after that, they say test. So here they've given you the forces. So now what you just need to do is to do the last part that you do for testing, and it will give you now that F. So how to usually test? Remember we said when we are testing, sum of upward forces is equal to sum of downward forces. So now let us look at all the upward forces. They are at A and B, which is 295. They're going up, plus 55 is going up, is equal to, look at all those that are going down, which is 200 plus 50 plus F. You see, that's what they needed there to calculate F. So when you do that, you add 295 plus 55. Actually, you can do that once to say 295 plus 55. Take 200 this side, which is negative 200. Take 50 that side, which is negative 50. Remember, when you cross the equal sign, you change the sign. That will now be giving us F. Now you can see we can do this once. 295 plus 55 minus 200 minus 50. Then that gives us 100 newtons. So F equal to 100 newtons. So that's what they wanted there to find. So F is equal to 100 newtons. It was just a good 3 marks for you there. All right. And then the next one, I think you can see there's an X there to say calculate distance X between force F and the 55 newtons by taking moments about B. You see now they are saying take moments about B, and when you take moments about B, it will make you calculate that distance xm. So if we're going to take moments about this force B, you ask yourself what is the effect of all the other forces, which is that, and that, and that. So let's start with the forces that are facing down. You can see about B, it will make this beam go in this direction, which is anti. Even this force will do anti, see, anti-clockwise by saying anti. Even this other force, it will produce an anti-clockwise. But look at A is the only force that will do a clockwise. So now I can actually use this information then in here to calculate. I'll just use this space here. Remember, it says sum of clockwise moments is equal to sum of anti-clockwise moments. So let's look at them there. Which one is the clockwise moment? It's A, which is 295, times what is the distance of A from B, which is 10 meters there. They are showing us as 10. There is no other force of clockwise, is equal to, you start with the 200 what is the distance of the 200 from the 55? I think they said, let me read this beam. They say the beam is 12 meters long. You can see the 200 is far end, so that is 12 meters long. So it's 200 times 12 times 12. That's the first one, plus, and then you look at the next part to say what is the 50 Newton force from B. So you can see that the 50, it is this distance altogether, which is, you need to add 2 and x, so it is equal to 50 times 2 plus x. That is the first part. And then the last one is f. You see that f times x, which is equal to plus the force F, which we found it was 100 newtons. Remember, we calculated it there, times x. So these are the forces that are acting, and then you just need to solve x. So what I do is 295 times 10 is 2,950 is equal to 200 times 12. I think it gives me 200 times 12 gives me 2,400, plus you open that bracket, 50 times 2 and 50 times x. 50 times 2 is 100, plus 50 times x is 50x, and then plus 100 times x is 100x. So you see how you solve it. Take 2,400 that side, take 100 that side, you'll be left with this side on the other side. So you'll have 2,950 minus 2,400 minus 100 is equal to 50x plus 100x is 150x. So when you simplify, finally you will have 2,950, right, minus 2,400, and then minus 100. If I do that, it gives me 450 is equal to 150x. Then divide by 150 so that we remain with x. You divide 400 by 150, so you will have, in this case, 450 divided by 150, and then gives us 3. So you can see that here x is equal to 3, and we're dealing with meters, so x there, that distance that they wanted there, it was 3 meters. So they say calculate the distance x between force F by taking moments about B. And then say the next one says name 2 practical applications in which the principles of couples are used. You see this question again, it is coming. 2 practical applications by which the principles of couples are used is the same question I said previously, to say you definitely need to know where to use them under examples. So the practical applications here, they wanted, you can say water spray, door handles, wing nut spanner, and thread cutter. They like such questions, or to say define a couple, as we said. So that is this particular question that they wanted. So I think I've done 3 more questions, and I hope this is benefiting to you guys. But now look at this one. I'm not going to work on this question because of my time, but the last question I wanted to do for you was this question on April 2016, and I want you to try it now, guys. You try this question. Let me bring it to you. I want you to try this question, and there is question 2. Just look at this question. It says a light horizontal beam is 15 meters long and is supported at the end, and it's supported at the end and 3 meters from the right end. The beam carries the following loads: 120 newtons 2 meters from the left hand end, 20 newtons 5 meters from the left hand end, 90 newtons at the right hand end, so they give you those forces that are facing down. And then says make a neat line sketch of the beam and clearly show all its dimensions and loads, 2 marks. Calculate the reactions of both points of support by taking moments about both supports. Ignore the weight of the beam, a good 6 marks. Then says check the answer by balancing upward and downward forces, and then you do the same. And we've been looking actually at all these. We've covered that, we've covered that, we've covered that. Now I want you to try this question. Now give me feedback if ever you struggled, and if you guys give me comments, that is when I'm going to be able to bring this question to you. But if you're not going to comment that you're struggling, I'll assume you guys managed to get this question correct. If you are struggling to find the answer to this question, remember to send us a comment or below this video to say, please can you do the last question. Just remember to say, please can you do the last question, or you can actually express where you are having a challenge, and then I'm going to do a video that I will post specifically for you who is having a challenge on this question. And I think this is not the end, the last part of the question here, because I didn't see the final mark. And then this is the question. Says a force of 250 newtons acts at 40 degrees to the horizontal. Calculate the vertical component, okay, of the 250 newton force. So this one, they are saying you've got something like this. You've got a horizontal, and in this horizontal we have a force that is acting at like that. See that? We have a force that is acting at 40 degrees to the horizontal, as you can see that, and this force is 240 newtons. Now they say calculate the vertical component. You must remember this force has a vertical component, and this force has also a horizontal component. This is 90. If you still remember, vertical is F sine theta, horizontal if it's F cos theta. Now again, if you're going to struggle with this question, remember to send me a message down below the video to say, please can you also do question 2.2, because you are struggling. It's a good simple question, but because of time I'm not going to continue that, because I wanted to say much concerning that question. So guys, we've come to the end of our lesson. Remember to subscribe again to our channel if you have not done so. It is very important for you to subscribe to our channel so that we can be able to bring these videos to you. And as you subscribe to our channel, also remember to share this with your friends and your colleagues, and also remember to in a way turn on that notification bell so that you are notified every time we post some new videos. I hope this was of benefit to you. We've come to the end of our lesson. Thank you.